That's I'm not sure. They have all their videos, but I'm not sure about it. Okay. Imagine an army so well trained that they're almost impossible to defeat. They attack the enemy and mutilate it, leaving them completely devastated. And then they spread. Today I'd like to inform you on the body's worst terrorist, cancer. And while this is by no means a comprehensive guide, I hope that you can learn a couple new pieces of information through this. Since I'm sharing an overview of the basics of cancer, I'd like to first start with how the first cancer cell is made, and then how that one cell goes on to create the mass that we know as cancer, and lastly, how to differentiate between cancers. Cancer is a term that's flown around quite frequently, but in order for someone to develop cancer, they first need to develop that first single mutated cell. But how? Simply put, cancer develops from one single cell messing up enough that it affects the cell's normal production. While cancer is always genetic, it is not necessarily always heritable. When it is, the problem occurs during meiosis, that is the division of germ cells. Here, the problem occurs as the chromosomes swap pieces of genetic information that allow us to be different from each other, allowing for the proliferation of our species. It is here when they swap genes that problems can occur, mutations, that can affect how the cells operate. In somatic cancer, the problem occurs during mitosis, the division of body cells. In mitosis, the brain, the nucleus, houses a smaller part called the nucleolus. And the nucleolus is all the genetic information that makes new cells. When a cell is about to divide, it doubles its genetic information, and then divides and gives each new cell a complete set. It is here in the DNA that problems occur. According to geneticcomreference.gov, updated July 22, 2013, cancer can also form de novo. This means that, as well as it being the starting point of cancer, it can also occur again in the sperm and egg cell, but it has no heritability factor. After the formation of the single cell cancer, it is ready to secondly go through and make the mass or tumor. According to cancerquest.org, updated May 23, 2012, cancer cells have 6 characteristics, which act also like steps. These often occur simultaneously and help form the cancer mass. When cancer first begins, a single cell mutates and starts to divide uncontrollably. It refuses to stop even when it crowds other cells. As it's growing, its mass increases, and it needs a growing supply to feed its insatiable appetite. So it reroutes blood vessels to feed it. Since it now has a path throughout the body, it uses these blood vessels as a highway to spread cancer throughout the body. This is why you can get liver cancer in your brain and brain cancer in your liver. This is also called metastasizing. In a benign tumor, this doesn't occur because the cells are encapsulated in a fibrous capsule, so while it can grow, it cannot spread. Besides the 4 characteristics I've already addressed, the uncontrollable dividing, the refusal to stop dividing, the rerouting of blood vessels, and the growing of the tumor throughout the body, called metastasizing, there are 2 other characteristics. It refuses to self-destruct when it notices something wrong inside its own cell, like a normal cell would do, and it never reaches a max number of cell divisions, again like a normal cell. However, not all cancer is created the same, which brings me to my third point, the differing forms of cancer. Cancer differs depending on where it forms. This is why you've heard of things called brain cancer that occur in the brain, and liver cancer that occurs in the liver, as well as breast cancer, which occurs in, the breast. However, in a more scientific aspect, cancer is also named after the area it forms in. According to Anatomy and Physiology, the Unity of Form and Function, written in 2004, different titles imply different origins. Lymphomas occur in the lymph nodes, sarcomas occur in the muscle cells, melanomas occur in the cells that control skin pigmentation, and leukemia occurs in the white blood cells, as well as the parts of the body that reproduce white blood cells, such as the bone marrow. Carcinomas are our last example. Again, according to the Anatomy and Physiology textbook, roughly 90% of cancers are carcinomas, the epithelial tissue, which we know as skin. This kind of tissue reproduces fast, which explains why there's a greater chance for mutations to occur, as well as a greater chance for a mass to develop, which explains why carcinomas are so common. Today I've given you an overview of cancer. I've explained how the first cell is created, how that cell goes on to create the mass or tumor, and how to differentiate between different kinds of cancers. While none of this is completely new information, I hope that through this, you can learn a little bit more about cancer and that it becomes a little less mysterious. Thank you for your time.